Solving trinomials when a is greater than 1. First, identify a, b, and c. To start reducing this trinomial, we first analyze if they all share a common factor. You can see that they don't. Now we move on to the next step, transforming our trinomial. We want to do this so we can have a simplified version of the original problem. Always multiply variable a times c to substitute c. This will allow us to get rid of variable a and simplify the whole trinomial. Now we're left with, at this step, always find two factors that together add up to b and multiplied equal variable
Let's try
c. 10 and 5. So 10 times 5 equals 50 and 10 plus 5 equals 15. No, it does equal 50, but it doesn't add up to 25. So let's try another one. 25 and 2 multiplied equal 50, yes, and 25 plus 2 equals 27. Nice, so we're going to use those factors. When completing our parentheses with our factored procedure, remember to always include variable a inside 2. Can this be simplified much more? Well, it can. 10 and 25 can be reduced 5 times. And 10 and 2 can be reduced twice. And you will end up with how to factor trinomials when a is greater than 1. First, find the three variables and label them a, b, c. We want to make our problem look like a basic trinomial in order to solve much easily. First, we can see that all of these three share a common factor. 2, meaning all of them are divisible by 2. We take the common factor outside of the parentheses. Always remember that you want to get rid of variable a to simplify this equation. To do this, multiply always a times c to substitute for c. Now we end up with this. When factoring, remember that you want to find two factors that added equal b and multiplied equal c. For example, we would end up with -5 and a +6. When arranging our factorization in parentheses, remember to always include your variable a and their common factor remaining outside or isolated. If possible, you can continue simplifying. In this case, we can. 15 and 5 are divisible by 5, and 15 and 6 can be reduced 3 times. And this will be our final answer. How to factor by grouping polynomials. It's very easy. You will normally get 4 sets of variables. In this case, we have c, 9c, 27c, and 27. Now we need to find pairs that share a common factor. In this case, we would get in 2 pairs of parentheses. In the first one, we get -9c squared plus 27c. and in the other pairs of parentheses that we factored is c cubed plus 27. Now we have to continue on factoring and simplifying. We can see that c cubed plus 27, we can find their difference of sum of cubes. So we will end up with c plus 3, and we continue on solving, following the proper rules. So we have c squared minus 3c plus 9. Now we have to factor the other one, and we will end up with c plus 3 parentheses c squared minus 3c plus 9 parentheses open parentheses c minus 3 close parentheses.
Hey guys, we're going to learn how to solve difference of cubes. You start by identifying if the variables and the coefficients have a cubic root. Next, for the first parentheses, you copy the sign from the original binomial, which in this case, it will be negative. Then, for the second parentheses, you will be creating a trinomial. Again, remember your signs. In this case, we are working with a negative in the original problem, since we are working with difference of cubes. So your first sign on your first parentheses of solution, it needs to be negative, copied from the original problem. The second sign, it will be positive, because it's the opposite from the first sign. And the last sign, it will always be positive. Just a hint. This is the same progress as in sum of cubes, but your original sign changes to a negative, and that affects the first and second sign. Hey guys, we're going to learn how to solve trinomials when a is equal to 1. You start by identifying your term a, your term b, and your term c. Then you look for two factors that multiplied give you term c and that added give you term b. And lastly, you put those two factors on a parentheses each one. You start by putting x and then your factors that can be positive or negative. Hey guys, we're going to learn how to solve sum of cubes. You first start by identifying if the variable and coefficient has a cubic root. Then, write the first parenthesis with the cubic root of each variable and coefficient. Since we are finished with our first parenthesis, we need to write our second parenthesis, which will be a trinomial. For the second parenthesis, our procedure will be: first, you need to square the term of a. Second, multiply a times b. And third, square the term of b. Remember of our signs. For the first sign in the first parenthesis of our solution, it will be copied from the original problem. Then, for the second sign, it will always be the opposite from the first sign. And for the third sign, it will always be positive.
In this video, I'll show you how to factor difference of squares. It is important to notice that you must only use the methods of factoring the difference of squares if the problem involves binomials, if the binomials are being subtracted to each other, and if both terms inside the binomials have a square root. It is also important to remember that the first step to any polynomial is to find the greatest common factor, and if you don't know how to take out the greatest common factor, you can look at our video called Common Factor with Any Polynomial. So the first step to this problem would be to analyze the function and identify if it is a binomial and if the binomial is being subtracted. So let's look at an example. In this example, you can see that a squared is being subtracted by b squared. So is it a binomial? Yes. Why? Because it has two different sets of variables. Is the two variables inside the binomial being subtracted? Yes. Here's a negative sign. And most importantly, do they have a square root? They do. So now we can address this problem. How do we do it? We start by placing two different parentheses and we look at the first part of the binomial. What is the square root of a squared? A. What is the square root of b squared? B. So the next step is to copy the first parenthesis into the second parenthesis. Remember, your answers will always have two different parentheses, so it is important for you to organize your space. The third step is to look at the signs. One of your parentheses will always be positive and one of your parentheses will always be negative. And this is how you address this problem. Let's look at another example involving numbers. Let's say t squared minus 11. So let's look at the three rules. Is this a binomial? Yes, it is, because it has two different parts to the problem. Now, do they have a square root? Excuse me, this is supposed to be 121. Does t squared minus 121 have a square root? They do. And are both terms being subtracted? They are. So now we can work on the problem. We start by placing two different parentheses and we say, what is the square root of t squared? And what is the square root of 121? 11. Now, we look at the signs. One's supposed to always be positive and one's supposed to be always negative. And this is the answer to the problem. Let's look at another example. In this video, I'll show you how to factor the greatest common factor of any polynomial. So to start with, the greatest common factor is the greatest factor that divides two different numbers. So to find the greatest common factor of two numbers, you must list the prime factors of each number. I'll show you how to do that farther in the video. So to start with, you must analyze the function by identifying it if it is a fourth polynomial, a binomial, or a trinomial. To see and identify which type of polynomial it is, you must look at the combinations between the coefficients and the variables present in the function. Coefficients are these numbers. Or the numerical values present in the function. And the variables are, in this case, x. So here, as we can see, there are three different combinations of a coefficient and a variable, meaning that this type of function is called a trinomial. So to start with, we must look first at the numerical values present in the function. As I said, they're called coefficients. And we must identify the greatest common factor of the coefficients. So 12, 18, and 24 are all divisible by 1, obviously. They're also divisible by 2, and they're also divisible by 3. But are they divisible by 4? No, they're not. Are the 3 coefficients divisible by 5? No, they're not. So now we look at 6. Are the 3 coefficients divisible by 6? Yes, they are. 12 divided by 6 is 2, 18 divided by 6 is 3, and 24 divided by 6 is 8. Now let's look at 7 to see if there's even a greatest common factor between the 3. 7 is not divisible by the 3 coefficients. 8 is not divisible by the 3 coefficients. 9 is also not divisible by the 3 coefficients. Now let's look at 10. 10 is also not divisible by the 3 coefficients. 11 cannot be divisible by the 3 coefficients, and 12, it's also not divisible by the 3 coefficients. So now that we got to 12, we can stop there because we can see that 12 is already part of the function. So we can't pass that number because obviously 18 and 24 will not be able to be divisible by any other number greater than 12. So the only number that we were able to identify as the greatest common factor was 6. Now let's look at the variables. X to the 5th power, x to the 4th power, and x to the 3rd power. In this function, we can see that the greatest common factor of the variables are x to the 3rd power. Why? Because if we take out 3, it won't make a change because we can't do 5 minus 3 or 4 minus 3. If we take out 4, that wouldn't help because we can't do 3 minus 4 because it will give us a negative number. We don't want negative numbers. Also 3 minus 5. So the least number present in the function is x to the third power. So we take out that x to the third power and place it right beside the coefficient. And now we can open parentheses. It is important to say that now we have found the greatest common factor. So let's start by dividing the whole function by the greatest common factor. So let's start with the coefficients. 12 divided by 6 is 2. And then when we want to divide variables, we will place the variable right beside the coefficient, and we're going to subtract, in this case, 5 minus 3. 5 minus 3 gives me 2. So now we just divided the first part with the greatest common factor. Now, let's try the second part. 18 divided by 6 is 3. But here, as you can see here, there's a positive sign. So we must also place the positive sign here. Now let's look at the variables. 4 minus 3 is 1. So we just put an x here right beside the 3. There's no need for you to put the 1 here, because if there's that is the same as saying this, because there's only one x. Now, here, this is a negative sign, so we must also place a negative sign inside of the parentheses. Now let's do 24 divided by 6 is 8. And let's look at the variables. X to the third power minus x to the third power is 0, right? So we just close parentheses. And that's how you look at the greatest common factor outside. And that's how you divide the function by the greatest common factor. You must then analyze the function to see if the polynomial, which is inside the parentheses, can be simplified with any other steps of simplifying other types of polynomials. And you must look for that video in our next videos, where we'll explain how to simplify trinomials inside the parentheses. So for now, this is the final answer. I'll read to you the steps so you can work on an example by yourself. So the example will be this one. You can now pause the video and work on it. Your answer should be z as the greatest common factor, and inside the parentheses, you must have 3y plus z to the third power. If this is what you got, you now understand the process. So, the steps to finding the greatest common factor of any polynomial must start by analyzing if the function is a four-term polynomial, a binomial, or a trinomial. Then, looking first at the coefficients inside the function. Third, taking out the greatest common factor of each coefficient. Then, taking out the greatest common factor of each variable. Then, you must open parentheses beside the greatest common factor and start by dividing each part of the function by the greatest common factor. When you finish doing that, you close parentheses, and there you got your answer. Remember, you must look at our videos about simplifying other types of polynomials inside the parentheses to be able to see if you answered your polynomial correctly. I hope you understand, and here are some other examples for you to work on.